No one told you life was gonna be this way. Your job's a joke you broke, your love life's the old way. It's like you're always stuck in second gear, when it hasn't been your day, your week, your month, or even your year. But I'll be there for you when the road starts to fall. I'll be there for you like I've been there before.
To discuss about potentiometers, about the description, how to work, and how to use it, and some other applications. This is a potentiometer. It is described as a resistive element that is variable, which is the most basic definition of a potentiometer. In 1841, it was invented by Johann Christian Poggendorf. Now, after its invention, there have been lots of different potentiometers, depending on the size, need, and function you need. Now, as you can see here, this one, there is something printed in there. It's a code that says how much resistance it can give. For example, this one says B100K. That means that it can give out 100,000 ohms, which is denoted by the word 100K. Some others do not print them in here, like this one, but they stick it in the back. It says here B10K. Now this one has smaller resistance since it can only give a maximum of 10 kilo ohms. There are also different types of potentiometers, although this is the most famous and most common one. And the most common function it gives is that it can give variable resistance. Some others do not just rely on resistance, they use it as a sensor, like displacement sensor or voltage divider.
So I'll be discussing about the working principle of potentiometers. First, let's discuss about its basic parts. I have here a potentiometer that we use in our electronics laboratory. So outside, it has a metal case, a rotating knob, and 3 terminals A, B, and C. Inside, it has a metal strip which gives the potentiometer its resistive value. Another is a sliding contact that is connected and controlled by the rotating knob. The wiper or the sliding contact is connected at terminal B and runs across the metal strip. I have here a schematic diagram of a potentiometer. It is simply a resistor with an arrow pointing inwards. That arrow represents the wiper or the sliding contact. At the opposite end, it represents the terminal B, and the other two ends represents terminal A or C and another terminal A or C. In order to understand how a potentiometer works, I have here an image of a potentiometer configured as a variable resistor. So the input is connected at terminal A and the output is connected at terminal B. Now, if the potentiometer is rotated counterclockwise, fully counterclockwise, its resistance value is at 0%. It is because the wiper is directly connected at terminal A and the wiper has no resistive value. As the rotating knob is turned clockwise, the resistance value of the potentiometer increases. Its output signal can be taken at terminal B and its value is directly proportional to the angular position of the wiper or the sliding contact.
While resistive potentiometer sensors have many advantages, low cost, low tech, and easy to use, as a position sensor, it also has many disadvantages, where due to moving parts, low accuracy, low repeatability, and limited frequency response. But there is one main disadvantage. The range of movement of its wiper is limited due to the physical size of the potentiometer being used. The potentiometer can work as a rheostat or as a voltage divider. To use the potentiometer as a rheostat, only two pins are used, one outside pin and the center pin. If we have a 10 kilo-ohm potentiometer, it means that the maximum resistance of the variable resistor is a 10 kilo-ohm. The minimum is 0 ohms. This means by changing the wiper position, you get a value between 0 ohms and 10 kilo-ohms. To use the potentiometer as a voltage divider, all the three pins are connected. One of the outer pins is connected to the ground, the other to the voltage supply, and the middle pin is the voltage output. When the potentiometer is used as a voltage divider, the wiper position determines its output voltage. When you have the potentiometer connected this way, you have the following circuit. Basically, the voltage divider is used to turn a large voltage into a smaller one. The output voltage can be calculated using the following equation obtained from the Ohm's law.
Okay. So that was potentiometers. I hope you learned something and I hope it was useful. Again, I am Jao, this is Dre, and this is Bri, and see you again next time. Bye! Bye.